In this section, we're going to learn how to solve quadratic inequalities. We know that quadratics have a square. That's how we can identify them. We know that inequalities will have an inequality sign of either greater than, less than, greater than or equal, or less than or equal. So we're going to combine those and we'll have a quadratic inequality. Now, there are several methods to solve these. The first is by graphing. So we already know how to graph this. If I were to give you this equation from our last chapter, you would know that A, if it's negative, it's going to point downward. You could find the vertex, but we're not going to. We don't really need to in this section. All we need to find are the zeros. And we know the zeros are the places where our function crosses our x-axis. And to find them, we can use several methods. We could use the quadratic formula. We could use zero factor property. Either one will work in this situation, and you could choose. But I'm going to try the zero factor property. And I know to do this, I factor this. So when my A is negative, I always factor out the -1. And now I'm going to factor my quadratic. And then I'll set each factor equal to 0 and solve. And I get 2 zeros at 1 and -6. So these are the places on the graph that we know our parabola crosses the x-axis. And we already said that we know that since it's negative, it's going to be pointing down. So I don't really need the vertex for this section. All I'm really concerned is this shape. I'm just going to sketch it in like this. We only need to know the shape of the parabola and the zeros because we're really only concerned about where is it above the x-axis and where is it below the x-axis. Because we know that our output, when it's greater than 0, it will be above the x-axis. So it's going to be this portion of our graph. So now we want to describe this with our x-axis as always. So we can see that we're going from here to here, right? And since we have a greater than symbol, we're going to leave that as an open circle. And we know it's going to be this interval between them. So our solution would be from -6 to 1, and it would be parentheses because they're open circles. If you were to make this on a number line, just picking up that x-axis, it would look like this. Let's try another one. Now, this is definitely a quadratic. I can see the square. It's definitely an inequality. It has a less than symbol. But if you notice, it doesn't have a 0 on one side. So let's move everything so that there's a 0 on one side. That's my first step. So I'm going to add 3x squared to both sides. And then I'm going to add x to both sides. And I'm going to rearrange it so that I'm in standard form. I just like the way it looks here. Easier to factor. Now, this is the same problem we had a minute ago almost. So I know that I can factor it. And I can solve for those zeros. So if this were equal to 0, so these are my zeros. They're the locations where my parabola crosses the x-axis. So let's go ahead and graph them. So at 2 and at -3. So all I need now is my shape of my graph. Okay, I don't really need my vertex. To determine if my parabola is opening upward or downward, I look at my A value. When I'm looking at this, make sure that I look at the one that has 0 on one side. Use that inequality. Notice the 0 here is on my right, and my a is 1. It's the number in front of x squared. So since it's a positive 1, it tells me that my parabola opens up upwards. If you're still struggling in this, remember that when a is positive, your parabola smiles like positive people do. When a is negative, your parabola is sad like negative people are. So our a is 1, which is positive, so it's going to be opening upward. Remember, I don't really need to find the vertex for these quadratic inequality problems. I just am really more concerned about how the parabola is acting. I want to know what regions fall above the x-axis and which regions fall below the x-axis. So once again, we're going to always go back to this inequality that has 0 on one side, and it has the symbols of less than. And this is very important because as you're getting the 0 on one side, you might change this direction of this inequality. Remember, if you divide or multiply by a negative number, it flips the direction. So don't look at the one that's printed. Look at the one that you created. Ours says less than. So where are the values less than 0? Where are my output values less than 0? Well, they're less than 0 here. So this is going to be our solution area. And remember, we always use the x-axis to describe this. So our solution is going to be in here. So now all we have to decide is, do we have open circles or closed circles? Well, since our symbol is less than, it doesn't have the word equal, we know it's going to be an open circle. If we wanted to show this on a number line, we could. We could say this is from -3 to 2, and it's an open circle. Or if we wanted to show it as an interval, we could, as from -3 to 2. Also use our graphing calculator to solve quadratic inequalities. So first, let's just put in the quadratic inequality into our calculator. I'm going to use my grapher. Now, if I graph this, I can see the parabola. But I want to also know where those zeros are, because as you've seen from the previous two problems, those are my important points that I'm going to look at. So I'm going to also set my second equation to be equal to 0. Remember, this is how we use the intersect function. It will really be an easy way to find those zeros. I say second trace, and then once again I use intersect, which is function 5. I hit the enter 3 times. 1, 2, 3. And it will automatically find one of your zeros. Now you may have 1 0, you may have 2 zeros, or you might have 0 zeros if your parabola doesn't ever reach the x-axis. So it doesn't matter which one it gives you first, you write that one down. So let's round to 2 decimal places. So we'll say -0.42. Now I want to find my other 0. So I'm going to say second trace 5, the same exact steps, but instead of hitting enter, before I do that, I'm going to use my right arrow key. I only use my right and my left arrow keys. Never use up and down. We're only going to use right and left to find that intersection point. I just go anywhere near the 0. It doesn't have to be exactly on it. And I hit enter, enter, enter. And now it gives me my second 0, 3.34. Now, if you want, you can even sketch this on your number line, the shape of the parabola. Okay, it looks something like this. All right, now, it asks us, where is our output greater than 0? And we know that greater means above the x-axis. So we're talking about values that I've highlighted. We use, though, the x-axis to show that region. So this is our region that we're talking about. And then we want to say, should they be open circles or closed circles? Are we going to include those end values? Now, the end values equal 0. and our symbol is greater than. So whenever we have greater than or less than, we're going to use an open circle. So if we wanted to show this on a number line, we could clear it out a little better so it's a little neater. Or we could show it in interval notation, depending on what the question asks us. Our next problem is a word problem. So I'm going to encourage you to just pause the video and read the word problem yourself. So this word problem tells a story about a tie manufacturer, right? And it tells us that they charge X dollars per tie. That's going to be our price. And then it also tells us that they sell 599.2 minus 12X ties. That's going to be the number of ties, or our quantity. They ask us to write a revenue function, and we know revenue is equal to price times quantity. So our price is X, and our quantity is 599.2 minus 12X. So we can distribute that and find our revenue. But in our particular case, they tell us that we want our revenue to be at least $5,376 per month. So I'm going to replace that with my RX, and I want my revenue to be at least that. So I'm going to use an inequality sign. Part B asks me, in what range should the company price each tie to keep the desired revenue? So we want to solve this because we know X is the price. Step one, always isolate this one side to be 0. So let's solve for 0 on one side. So we're going to subtract 5,376. And I'm going to go ahead and rewrite this in nice standard quadratic form, just rearranging my terms. So I can clearly see this is going to be a quadratic. It's going to be a parabola, and I can use my inequality method we already talked about with the calculator. Get those graphing calculators out, and let's enter our inequality into our grapher. So I've entered it in for y1. y2, we're going to always set equal to 0. Then we can use our intersect. We're going to change our window. And they gave us the window in our problem. So we're going to say -2, that's our x-min, 50, x-max. Our scale is 2 for the x-axis. Y-minimum, -10. Y-maximum, 8,000. And your Y-scaled, 500. Now let's graph it and take a peek. We want to find these two zeros, one here and one on the right. So we're going to say second trace 5. And then I'm going to hit enter 3 times. And it gives me my first 0 as 11.73. Now I want to find my second 0. So I'm going to hit second trace 5. And I'm going to use my right arrow key to move it closer to the right 0. Notice I'm only going to use my right or my left. Never use your up or down. Anywhere near it, it does not have to be on it, and you just hit enter, enter, enter. And it will find that second 0 at 38.21. Now, you can sketch them in your number line if it helps you. And I know that my inequality that I created before I graphed says I'm looking for values that are going to be greater than or equal to 0, right? Now, if this is confusing you, sometimes people, when the variable is on the right, it confuses them. So just go ahead and rewrite your problem, swapping the direction of the sign. If that helps you, see, I just changed it from, it was pointing to the left, the arrow was pointing to the left, now it's going to be pointing to the right. Now I can see I'm looking for values that are greater than or equal to 0. They're going to be the values in here. And I know it's going to be a closed circle because I have the equal on the bottom of the inequality. I could write that also as an interval